Welcome back, everyone. Today we're going to be going over the proof of the sum of cosines sum to product identity, so let's dive in. All right, so the first thing I'm going to do is we're going to let C be equal to A plus B over 2, and we're also going to let D be A minus B over 2. And the reason I'm choosing these for our new variables of C and D is because over here we have A plus B over 2 inside this cosine. And then over here we have A minus B over 2 inside of this cosine function. And so doing this will be useful to us. This is going to help us later on. Okay, so now I'm going to express A and B just in terms of C and D. So to do that, for this one here, I'm going to start by multiplying both sides by 2 and get that 2C is equal to A plus B. And then over here, same thing, that 2D is equal to A minus B. And now I'm going to solve for both in terms of A. So A is equal to 2C minus B over here. And over here, A is equal to 2D plus B. So now let's let this be equation 1 and this be equation 2. I'm actually going to add the full equations together. So that means I'm going to add the left sides together and I'm going to add the right sides together. So A plus A just gives us 2A. And then we have 2C minus B plus 2D plus B, right? Because I just took both these right sides. I added them together to get this. And then I'm going to cancel out these B's and divide both sides by 2. And we get that A is equal to C plus D, like that. Okay, and next we're going to do the same thing, but for B. So going back to this step here, if we were to write both of these equations in terms of B, if we start with this equation right here and write it in terms of B, we get that B is equal to 2C minus A. And then if we do the same for this equation over here, we write it in terms of B, we get that B is equal to A minus 2D. And now same thing here, I'm going to add up these two new equations to get another one, to get that 2B is equal to 2C minus A plus A minus 2D. I'm going to cancel out my A's, divide both sides by 2, and I get that B is equal to C minus D. And there we go. Let's write that a bit better. C minus D. All right, so now you might be thinking, well, what does this have to do with anything? Well, the thing is, based on what we wrote, we're going to start with the left side and then derive the right side from it using the definitions we've just given and the math we've done. Okay, so the key things to remember here are these two, right? How we originally defined C and D, and then also how we derived A and B from that. So here's A and here's B. So therefore, cosine of A plus cosine of B is equal to cosine of C plus D plus cosine of C minus D, right? Because all I did with this step is I subbed in A is equal to C plus D, and also B is equal to C minus D. That's what we did there. Now I'm going to use the sum and difference formulas for cosine in order to figure this out further. So this is equal to cosine C cosine D minus sine C sine D, right? So this part here, cosine of C plus D, recall that that is equal to cosine C cosine D minus sine C sine D. Then we're going to add the next part, which is going to be cosine C cosine D plus actually in this one, sine C sine D, like that. So recall that this is the same as this for our difference formula for cosine. Okay, now I'm going to collect like terms. So these two can cancel out and we'll end up with 2 cosine C cosine D. And C was equal to, if we go back and just review what was C equal to again, C is equal to A plus B over 2. So 2 cosine of A plus B over 2. And then D was just equal to A minus B over 2, like that. And so therefore, if we go back here, we can see that we have now proven it. We've proven that cosine of A plus B, or sorry, cosine of A plus cosine of B, which very different, is equal to 2 cosine of A plus B over 2 times A minus cosine of A minus B over 2. And so we have now proven this. All right, if you have any questions, please leave those in the comment section, and we'll see you for the next one.